Back to once again the new session of operating system programming concepts, and here the topic for today is process synchronization, and I will go through some important key concepts for program synchronization and some key concepts that is mostly related with doing the programming that is related with or solving the programming problems which is related with programming synchronization or trying to synchronize by the means of programming. Okay, so we'll go through this, how to synchronize the process, and we will implement it in a programming problem. So before starting the session, okay, I will just go through our traditional concept of humor. So it says most innocent robbery. Okay, so as the thief left the house, the kid awoken and said to the thief that take my school bag, you bloody, okay, or I will just wake up my mommy. So this was the situation, the most innocent robbery that occurred in a house, okay, like some 10 or 20 years ago. Okay, now let's begin the session. Okay, so the first question of this session is like, which system call do we use for process synchronization? So the system call that you use for process synchronization, I think you guys have already known it. That is a system call called wait, because I have already discussed this in my previous operating system concept lectures, right? So you know the basic format of this system call is this. It's just waiting for the status, and the return type is a identifier, process identifier, right? So and what it does, it blocks the calling process until one of its child process exits or a signal is received. Okay, and performing a wait allows the system to release the resources associated with the child, because you guys have to understand the basic concept is like whenever a system called fork is used, then the child processes are generated. Okay, these child processes, which are very identical to the parent processes which generate this kind of child processes, these child processes can take some of the resources, okay, which can like use the resources of the parent, or which can not really use any kind of resources. Okay, so it depends. So if this kind of child resource processes also does any kind, like the next system call, that is the exec, which just directly also perform another program. Okay, this exec system call is going to take you to the another program, okay, and try to execute the another process. So in this way, there will be some kind of resources which is which is used by this child process. So all these child processes resources which the child process use, by performing the wait, the system will just recover all this kind of used resources by the child. And like if a wait is not performed, then the terminated child process becomes a zombie process. Okay, remains in a zombie state, it is said that. So what is this zombie process overall? This zombie process is something like a defunct process, okay, that has completed execution but still has an entry in the process table. That means something like a process that has completed, okay, its execution, but still it has an entry in a process table. So if you guys can check out here, the example of a zombie process is something like this. Okay, like the main concept is like, okay, look, we did a fork here. Okay, if the fork returns 0, that means it's a child. And right now you guys can check out, child is not exiting, but and in the parent block, what the parent does is just prints out the statement that the parent PID, and it also prints out it is going to sleep for these seconds, and it sleeps for these seconds. So here what the parent is doing is parent is just sleeping. Okay, it's just doing for and then he's just sleeping. That means he's creating child processes, then he's just sleeping out. Okay, he's sleeping for almost like 20 seconds. So what happens in this particular situation is that like the child process just exits, okay, complete the execution, but the parent do not recover the child resources. Okay, so the entry table still has the entry of a process, okay, of the child process. So still in the process table there is an entry of a child process. So and also the parent process, the entry is still there, right? So the idea is like here, if the parent do not use the system called wait and do not recover the resources, then it is going to create some process like a zombie process. So this is the basic idea. Now, what is the orphan process? The orphan process are the process that are still executing. So that means the child are still executing. They have not finished execution. Okay, whereas the parent has already executed. So it's like just the opposite case than zombie. You guys can check out here, right? Like the example. What is done is like the fork is created here, right? So after the fork is created here, in the child block, the child sleeps. Okay, look at here. The child prints out his parent process ID, then also the parent process ID. Then he sleeps. He prints out the statement that sleep for something second, and he just sleeps. Okay. So and here what the parent is doing is just printing out the statement and executing immediately. So there is no wait is called, no waiting for the children is occurred here, whereas the child is just sleeping for 20 seconds. So parent will execute before the child, and in this situation the orphan is created, right? So now you guys have to understand that whenever the orphan child processes are created, they do not become a zombie process. That means they do not have any kind of entry in the process table. But what is done is these are adopted by the init process. These are the root process, which have a process ID 1. Okay, and the job of this main process is to wait for this children process. Alright. So lastly, here I have a system called PID, which is the same system called like a wait. Okay, you guys go and check out the okay, let's go and check out the terminal. From the terminal, okay, if you process for man, wait PID, there is no man. Yes, you guys can check out the manual, and the manual says that this wait PID, wait ID waits for process to change the state. Okay, and the particular synopsis or the format or the syntax is something like this. Okay, for wait you guys already know, whereas for wait PID it waits for the particular PID process. Okay, so PID process status. Okay, and options are also like kept here. So similarly, the description you can check out, like all of the system call are used to wait for the state changes in the child of a calling process and obtain information of the child which state have changed. Okay, so a state change is considered to be the child terminated. The child was stopped by the signal, or the child was resumed by the signal. So some kind of cases occurred here, and the wait system call suspends execution of the calling process until one of the children terminates. Whereas you guys can check out here the wait PID. This one is same with wait, calling wait, and wait PID are same, but the only difference between wait PID is that waits for the status of a particular PID, the process ID of that child having the particular process ID, and that is passed as a parameter. Just waits for that child status. Okay, so it blocks all the calling process until this child process on this child specified by the PID has changed the status. Okay, state. Okay, this is all about this kind of some basic concept about process synchronization. We will go later on. We'll go about in the laboratory session, and we'll try to solve lab number 4, which is related with this process synchronization. Okay, thanks for listening.